Yes, we are the Quality Quesadillas, and this is our product, Greg, the GeoguessR Expert Guesser. Yeah. Hi, I'm Chris. I was product manager and also on machine learning, so I helped with a lot of things, including gathering data, training the model, and also PyFlask.
Hi, I'm Tanay, and I worked on the backend code generating data from APIs and also machine learning.
Hi, I'm Aviv. I worked on the front end and I also worked on gathering data and working on the actual model itself.
I'm Warren. I worked on the machine learning and I helped with everything. I helped gathering data and editing the video.
Hi, I'm Sohma. I create the logo and I also helped out with gathering data for the machine learning model.
I'm Leo. I was in the machine learning team and I helped with video editing, making presentations and gathering data.
And hi everyone. So I'm Mohak. I was an instructor for Quality Quesadillas, and I guided the entire team whenever they needed my help.
Yeah, so our minimum viable product or MVP is to locate what country the photo was taken from. So the 5 countries: Brazil, Canada, Finland, Japan, and France. And within the generated results, we were hoping to have at least an 80% accuracy.
All right, so for a quick backstory of our project, so a few months ago, I discovered GeoguessR, which is a video game in which you are placed in a random Google Maps street view location, and you try to pinpoint exactly where in the world you are. And I was kind of hooked. So when our project brainstorming began, I proposed the idea of a GeoguessR AI, and our team agreed that this would be an interesting project, so we chose it, and here we are now.
Okay, so the data gathering methods. So we used 3 tools, which was Mapillary. Mapillary is a platform that makes street level images and map data available to scale and automate mapping. And it was extremely useful when it came to data gathering because we could download all the data directly. However, we figured out that this is like really time consuming since some of the pictures had really low quality. So we also got some screenshots from Google Maps Street View since they had higher quality for the photos. And we also got some pre-made datasets, which helped us a lot since we didn't have much time towards the end of the project, and made our model much more accurate.
Yeah, so Greg took on 2 other forms before we actually got our final ultimate Greg. So the first model, we actually had 6 countries, which was Australia, France, Japan, Mexico, New Zealand, and the US. And we were very naive and we thought that 100 images per country, which was 600 in total, on top of a pre-trained ResNet 50 CNN would be totally fine. And we got most of our images from Mapillary API. It worked on a 1 Mapillary image, and I'm pretty sure all the other GeoGuessr screenshots, it definitely struggled a lot more. So then the second time around, we quadrupled the amount of data, which was 400 per country, and with RoboFlow's augmentation, which was RoboFlow is the dataset creator that we used. With its augmentation, we got around 3,000 images in total. And again, as Soma previously stated, because of Mapillary being not the highest of qualities, we decided to take a lot more screenshots in this second model. It got a 99.8% train accuracy actually, but a 78% test accuracy, which was not quite our goal of 80%. So in the end, it worked all right, but it wasn't great. And then afterwards, after a quick Google search, we actually managed to find a pre-made RoboFlow dataset with around 1,500 images per country. And in this case, it was formatted similar to our dataset. So we decided to take a lot of those pictures. And because of that, we also revamped our model to be trained on the 5 countries instead of Japan, Finland, France, Brazil, and Canada. And it reached an 85% test accuracy, which we were definitely satisfied with.
Okay, so for our limitations in Roblox, our main limitation is that there's only 5 countries that it can distinguish between because of one time constraint, since we only have 3 weeks, and to gather all that data would be pretty hard. And then 2, the lack of data, because it would need tons and tons of data for us to create a model that functions well and covers around 200 countries. And then another problem that we went through was that our model prefers pictures of streets and doesn't work well with pictures of other things, like in a park, or for example, it wouldn't really work. And then the model really doesn't look for specific items to distinguish the countries, but instead uses the entire image, which makes it necessary to have a lot more data than if it looked for specific things. And then building off the previous problem, sometimes the model distinguishes the countries by things that aren't accurate, but if things are accurate, like for example, if it is a rural area, then it is France, which obviously isn't true.
And now it's time to show a demo of how our model works. So I have a game pulled up of GeoguessR in Japan. So as soon as we start the game, we can take a look around and we can get a few pictures. So let's say that this is the picture that we want to provide to our model. So you just screenshot your image, and then you just save it. And then whenever you go back to our website, you are now able to hit this talk to the AI button, and it will bring you to, if you give it a second to load, it'll bring you to this page. Now, in order to upload your image, you simply click on that box and then you upload your image. In this case, this is my image that I just got, and then you hit predict. And then over here, it will return the confidence values. So it's pretty confident that's Japan, which is indeed correct. And then if you want to really just add another image, you can just hit try. You can just hit try again, and then you can add another image. This is another image of Japan that we got earlier during our testing. And if you hit predict with it, it will say 100% Japan. Thank you all for watching our presentation.